All right, so let's change the number again from 13.7 to 12.5. Okay, so the normal curve is basically a distribution shape. So the normal curve is going to be a bell-shaped curve that looks like a bell. That's why they call it the bell-shaped curve. And for the most part, it's symmetric. It doesn't always have to be perfectly symmetrical, but most of them, or sometimes it will be. And so that just means that most of the population falls between here. As you can see, it's higher here. That means most people fall here. So you can think of heights of men or heights of women are normally distributed because you have very few people that are like short. Let's see, I think the mean height of men is somewhere around 60, what is it? I think it's like maybe 62 inches tall. And then, they get shorter and shorter. And then over here, you get taller and taller. So over here, you'll have someone that's very tall. And over here, you'll have someone that's very short. And so there's very few people in the population that are short and very few people in the population that are tall. Most people are in these average range, which is around here somewhere for men. And for women, it'll be a little shorter. But that's an example of normal distribution, the heights of men or the heights of women. There's many examples. IQ levels, that the mean is 100 for IQ. And then you have lower IQ, higher IQ. There's very few people in these two ranges, but there's a lot of people. The majority of people fall in between here, in average range. All right, so let's see, skewness. Skewness means that you don't have a bell-shaped curve. You're skewed either to the left or you're skewed to the right. So here are the different shapes. Skewed left would look like this, because the tail is to the left. So that's what they mean by skewed left. The tail is on the left side. Skewed right would mean that the tail is on the right side. And then symmetric means you have a bell-shaped curve, which is a normal distribution. All right. The mean substantially smaller than the median. So if you're looking at a distribution that's skewed left, that means the mean is going to be less than the median. And then for symmetric, they're going to be about the same for the most part. The mean and the median will be approximately the same. And if you have a skewed right distribution, that means the mean is larger than the median. So the mean is going to be bigger than the median. All right. They give you some characteristics of the skewed left distribution. It has a longer tail on the left. The mode is bigger than the median, which is bigger than the mean. All right, so the mode is the largest, and then the median, and then the mean is the smallest. For symmetric, they're all approximately equal, right in the middle. And skewed right, the mode is the smallest, the median is in the middle, and the mean is the largest. So mode, median, mean. All right. It says here, outliers to the right, pull the mean to the right. So if you have some outliers, like someone who's really tall, they're going to pull the mean more to the right. All right. And if you had someone that's extremely short, it's going to pull the mean to the left. All right. Here is a normal distribution because it's roughly symmetric. It's not perfectly symmetric, but it's roughly symmetric. So this would be considered a normal distribution. Whenever you have something that's sort of symmetric, they refer to it as a normal distribution. All right, another name for that is Gaussian distribution, named after the famous German mathematician Gauss, but most people just refer to it as a normal distribution. All right, so the characteristics are it's bell-shaped. The frequencies start low, and then they increase to some maximum, and then they begin to decrease. The distribution should be approximately symmetric about the mean. The mean is going to be in the middle, and it's roughly symmetric on both sides of the mean. All right, the normal distribution is important because many sets of data are normally distributed. So we mentioned a few: heights, weights, IQ. Let's see, what else is, trying to think off the top of my head if I know of any others. Well, we'll run into some more examples. Head sizes for babies or something. Head sizes for newborns. All right. All right, z-score. So what is a z-score? It explains it here as the z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. So remember we went over standard deviation in the previous section. So the z-score represents how many standard deviations are you away from the mean. So I'll just show you the picture. This is the mean. The mean is always in the middle for a normal distribution. This would be 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. To the right, this would be 1, 2, 3 to the left. So this would be a z-score. This is a z-score. These are the z-scores. The z-score is 1 because you're 1 standard deviation away. The z-score is -1 because you're -1 z-scores away on the left, so on and so on. All right, it is obtained. It is obtained by subtracting the mean from the data value and dividing this result by the standard deviation. So here's a formula. You take a data value, like someone's height, for example, you subtract the mean, the average height, and then you divide that by the standard deviation, and that tells you the z-score. This is the same thing, it's just instead of the mean, this is sample mean. So let me write that. Sample mean, population mean. Oh, they say it here, population versus sample. This is sample standard deviation, population standard deviation. All right, we'll do some examples to make this make more sense. All right, so here it is. The standard normal distribution is a bell-shaped curve. The standard normal distribution is a normal probability distribution. The mean is 0. Mean is 0, and the standard deviation is 1. So whenever that's the case, whenever the mean is 0 and the standard deviation is equal to 1, they call that a standard normal distribution. If it wasn't 0 and it wasn't 1, but it was still bell-shaped, then it would just be a normal distribution. But if you make the mean 0 and the standard deviation 1, then it becomes standard normal distribution. So that's the only difference between a normal distribution and a standard normal distribution. The normal distribution has a mean that doesn't have to be 0 and a standard deviation that doesn't have to be 1. But a standard normal distribution has to have mean 0, standard deviation 1. All right, the other characteristic of any normal distribution, doesn't have to be standard, any normal distribution, is that area under the curve is always equal to 1. So the area that I just shaded is always equal to 1. All right, so if you are shading only this much, I would say that's probably maybe like 80% of the graph, because this would have been maybe 20, this is 80. So this would be 0.80, this would be 0.20. That's just my guess, but we'll see. So this is called a non-standard normal distribution because the mean is not 0. This is called a standard normal distribution because the mean is 0. All right, so what this formula does is it standardizes the data value. So it forces it to be standard normal distribution. So if your mean is not 0, you could turn it into 0 by applying this formula, and then you will have a standard normal distribution. So you can always convert it using the formula. Use z-score formula to convert a normal distribution into a standard normal distribution. So sometimes you want it to be standard. You want the mean to be 0 because you're going to be able to use a table. You'll see this table that I'm going to provide you with to find out the different probabilities. If you don't have the table, if you don't want to convert it, you don't have to. You just have to have a TI-83 or a TI-84. And that way you don't have to convert it using the formula. You can just use your graphing calculator, which I will show you how to do. It's super easy on the calculator. All right, once you find the z-score, then you're going to be able to find the corresponding probabilities. So here is so using a table, it is designed only for standard normal distributions. So that's why you have to convert if you're going to use a table, because the table only works for standard normal distributions. It doesn't work for any normal distribution. It is on 2 pages. One has negative z-scores and the other has positive z-scores. The table gives the area under the standard normal curve for values to the left. All right, so the table is always going to give you the area under the curve for values to the left of a specified z-score. So if the z-score is -1, it's always going to give you the area to the left. It's not going to give you the area to the right, always the area to the left. All right, so let me show you an example. This is what the table will look like. I will provide it for you. All right, so let's just go ahead and do an example because it's too confusing if you don't. Let's look at this one here. Find the area under the standard normal curve. So they want us to find this area. How do we find the area? We have to use the table. Luckily for us, the mean is 0. That means it's standard. Oops, I misspelled that. Distribution, just distribution. Because the mean is 0, that makes it a standard normal distribution, which means we can use a table. You're given a z-score, so you have to look the z-score up on the table. So it's 1.27. So you would go to 1.2, and then you scroll to the right until you hit 7, 1.27. There it is. So it's 0.8980. So that is the area under the curve, 0.8980. And it turns out that probability and area are basically the same thing in this context. So whatever the area is, that's your probability. So it's the same thing. So the probability is like almost 90% chance. And we'll look at some real world examples where this would make some sense, like how it's used in the real world. All right, let's move on to the next one. So here's a table for the negatives. All right, they want us to find the area under the standard normal curve to the left of z equals -1.85. So first thing you always want to do is draw the picture. So let's draw the picture. Draw your bell-shaped curve. All right, your mean is 0 because it says standard. So that tells you that the mean is 0. All right, -1.85, negative is to the left, positive is to the right. So we have to draw a line at -1.85. That would be approximately, who knows, probably around here somewhere, -1.85. And it says to the left. That means we have to shade the left because that's what it says. So shade the left. All right, so we need to find this area. That's where you have to use the table. So you have to look up -1.85 on the table. So here's -1.8. And then you have to go all the way to 5, which is right here. So you would go negative 1.8. And then you would go 0.5. There it is. So it has to be 0.0322.
Mr. Onales, why 0.5?
Oh, because it's negative 1.85. And this one's only negative 1.8. So you have to go to the 5 in the for the second decimal value.
Oh, I see. I see. Okay.
Yeah, there it is. So there it is. And then,
all right.
all right. So our final answer is 0.0322. That's the area under the curve. All right. So that's how you use the table. Let me put the table in the chat so that you guys will have it. Chat, table. All right, this is math 120. All right, where did I put it? I think I put it under notes. Yeah, here it is. All right, you should see it in the chat room. All right, they also show you how to do it using the calculator. I think some of you have a graphing calculator, right? So let me show you how to do this on your calculator. So let's say you wanted to find this, but you didn't want to use the table. So you would go, let me show you the calculator first, and then I'll show you the steps. The table. All right, so you go to second vars. That's the distribution. If you look up there, DISTR, that stands for distribution. Here are all the distributions. There's a lot of them. You want to go to the second one, normal CDF. Normal CDF. And then they want you to type in the lower. The lower is, you just have to pick a number that's all the way to the left on the number line. I always like to pick negative 9999. That's a really, really big number in the negative direction. And then your upper value is, in this case, if we're doing the same example we just did, negative 1.85, negative 1.85, and then your mean is 0, your standard deviation is 1, and then you just paste. And you should get the same answer that the table gave us, approximately 0.0322 if you round. Yeah, 0.0322 is exactly what we got. They just rounded this number up. So the calculator is a little bit more accurate, but the table's fine too. So that is how you use your calculator. The reason why I put lower negative 999 because you're going all the way to the left, negative 9999, and the upper, this is the upper value, which is negative 1.85. So that's the reason why we did that. So here are the directions. TI-84, second vars, which is distributions, down arrow to normal CDF, enter your lower limit, your upper limit, your mean, and your standard deviation, enter. All right. Here's the IQ example. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Notice it's not standard because standard has a mean of 0. This one is a mean of 100, so it's not a standard normal distribution, it's just a normal distribution. All right, find the percentage of individuals with IQ scores below 115. So first thing we should always do is draw the picture. All right, the mean is 100. It tells you right here. The standard deviation is 15. We want to know the percentage of individuals with IQ below 115. So 115 is bigger than 100, so it's going to be over here somewhere. You can just draw a line anywhere that's to the right of 100. And because it says below, that means you need to shade the left side. If it would have said above, you would have shaded the right side. So we have to
What
shade
line was that, Professor? What line was that you just draw going down?
the 115
On the
line.
graph, on the graph, to the
Yeah.
right.
Yeah, the 115.
Oh, one. Oh, okay.
Yeah. So then you shade to the left because it says below. If it would have said above, you would have shaded to the right. All right, so now we have to find the area of that I just shaded. We have to find this area. We can't use a table because the mean is not 0. So you can only use the table if the mean is 0. So let's do it 2 ways. Let's use a calculator for now, and then I'll show you how to do it with the table. All right, so first thing we have to do is use that formula. Remember we said if it's not a normal distribution, you have to use a formula to make it normal. I'm sorry, standard. So here's the formula. So let me copy and paste it. All right, so the X is the data value. The X in this case is 115. That's your data value. Your mean is 100. And your standard deviation is 15. So if you work this out, you're going to get 15 divided by 15, which is 1. All right, so now you know your z-score. All right, so now you could redraw the graph all over again. The same exact graph. This time the mean is 0, and the 115, we just converted it into a z-score.
Wait, Mr. Hernandez, I'm sorry to interrupt you, but how did you get Z equals 1?
Oh, okay, because first I did 115 minus 100. That's 15, right? If you do that,
And it cancels out.
yeah, 15 divided by 15 is 1.
And you
Okay.
only use this formula only when it's not 0 to get it to 0. Oh, okay.
Exactly right. You only have to use this formula when it's not 0. The mean is not 0 in order to make it 0. So once you've converted this into a z-score, now you can, instead of writing 115, you would just write 1 because that's the z-score 1. Instead of 100, it now becomes 0. And you're still shading to the left. It's the same exact picture. The only thing that changes is the numbers, because now you can use the table. Before you couldn't use the table because it's not standard. This is not 0, but now that it's 0, now you can use the table. So you go to 1. Let me share my share the table with you guys so we can use the table to find the area. Hold on. Okay, math 120. Lecture notes. Okay, here it is. So we have to look for 1 on the table. So see, these are the negative ones. You don't want negative, you want positive. So you go to the next page, and the next page has all the positives. So here's 1. And you don't need the hundreds place is 0. So it's just the very first one. It's going to be this one right here. 1.0. So the area is the area to the left. See, they draw a picture for you. The area to the left, not the area to the right, is 0.8413. 0.8413. And that is the final answer. All right. So that is that's the percentage of people that have a IQ score below 115, which is the majority of people. 84% of the population is going to have a IQ score below 115. Because remember, the mean, the average is 100. So, so that's how you would do it. If you don't want to use a formula and you have a graphing calculator, let me show you, remind you how to do that again. You go to second bars, second vars, normal CDF, which is number 2. And then your lower is still -9999 all the way to the left. And your upper is 1 this time, positive 1. And your mean is 0. Your standard deviation is 0. And you should get the same number that we got, 0.8413. That's exactly what we got, 0.8413. So now you have 2 ways, if you have a graphing calculator, to do it. You don't have to convert it into a standard if you have a calculator, but if you don't have a calculator, you do have to use a formula to convert it. All right, so now, same kind of question, this time below. Oops. What is happening? All right, so first thing you should always do is draw your distribution. The mean is 100. The standard deviation is still 15. This time they want below 70. 70 is to the left of 100, right? So this time you have to draw your line to the left of 100 because 70 is below 100. If it would have been 170, you would have been way over here, 170. So think of this as a number line. 100 is in the middle, 70 is below, 115 is above. All right, so 70 we have to shade below, so shade to the left. All right, let's pretend, or let's assume that we do not have a calculator. So first we have to use
Mr. Hernandez, didn't we already shape to the left?
well, this is a different problem. This was,
Oh, I see.
yeah, we're doing a separate problem.
Okay.
But yeah, because the mean is not 0, that means we have to use a formula to convert. So let's use a formula again. Z is equal to X. Remember, X is the data value, which is 70, minus the mean. The mean is still 100, divided by the standard deviation, which is 15. So divide by 15. This time you're going to get -30 divided by 15, which is -2. So your z-score is -2. All right, so now we got to go to our table that I dropped in the chat room, and then go back to the negatives. Here's the negatives on page 1. -2 is right here, and it doesn't have a hundredth place, so it's just 0. So it's going to be the very first one. So it's 0.0228. 0.0228. 0.0228 is our final answer. So only about 2% of the population has an IQ level below 70. So a very small percentage of the population. All right, so that is it. If you want to try this on your calculator, you would do second.
Can you show us an example of how to do it to the right?
Oh, to the right? Yeah, I'll show you. Well, all you have to do is remember the whole thing is 1, right?
Uh-huh.
So to find this, it's called the complement. You find the complement, you do 1 minus 0.0228, and that'll give you that. So it's basically the 1 minus this number. So if you do that on your calculator.
Can you do it on the calculator, por favor?
Yes. So if you do 1 minus 0.0028, you're going to get 0.9772. So I just did
Okay.
1 minus this number, and that gives you the right side. And you can
Okay.
you can do the same thing over here. 1 minus 0.8413 will give you that. So 1 minus 0.8413 is 0.1587. So you always subtract from 1 to get the right side. All right. I think this is a good time to take a So the lower is 18, the upper is 9999. The mean is 18, and the standard deviation is 4. You should get 0.499999, which rounds up to 50. So just like we predicted, it is 50% of the students who work at least 18 hours. And the reason I knew it was going to be 50 is because it was right. It was the same as the mean. 18 is right in the middle, and therefore it's 50% to the right, 50% to the left. All right, if you don't have a calculator, then let's use a formula. All right, so here's the formula. Z equals X minus mean over standard deviation. The data value is 18. The mean is also 18. The standard deviation is 4. 0 divided by 4 is 0. So your z-score is 0. If you go to 0, it's 50%. So you get the same answer. So if you redraw it, you're going to get the same answer. All right. Oops. 0. All right. So you get the same answer. All right. Let's look at the next one. Let me see. Is there another page or is this it? Yeah, there is a couple more. We might have to finish this off next class. Let's just do these last two problems. And then next class, we'll finish off the last two problems on the next page since we're going to be out of time soon. All right. So this one says.
Oh, we have the test this Sunday, don't we?
No,
No, next week. Yeah, it's next week.
Oh, it's next week.
Yeah. So we'll have,
Oh, okay.
yeah. So find the percentage of college students who work between 14 and 26 hours per week. So let's draw our normal distribution. All right, remember the mean is 18. So 18 goes in the middle. The standard deviation is 4. This time they want us to find the percentage of college students that work between 14 hours and 26. 14 is to the left, 26 is to the right. So 14 would be somewhere over here. 26 would be somewhere over here. And between means you're going to shade everything in between. All right. So first way to do it is normal CDF. If you have a calculator, that's always the easiest way. The lower is 14, the upper is 26. So lower, upper, the mean is 18, and the standard deviation is 4. So if you type that into your calculators, let's see what it is. I'm getting 0.8186 if I round. All right. So now let's do it without the calculator. So the formula is Z equals X minus mean over standard deviation. All right, we have to do it twice. One for the 14 and one for the 26. So let's do the 14 first. So 14 minus the mean, 18, divided by 4. That's going to be -1. All right, let's do the same thing with 26. Z equals 26 minus the mean, 18, divided by 4, the standard deviation, you should get 2. All right, you should get 2. All right, so now you can redraw the distribution all over again. This time your mean is 0, and your z-score is -1 on the left, +2 on the right. You're shading in between. All right, and now remember what we did last time. You have to use the table to find the area to the left of 2. So we've already done this one. It's 0.9772, 0.9772. And then you have to find -1. -1 on the table is 0.1587, 0.1587. And then, so from here to here, it's 9772. From here to here, it's 1587. The way you find in between, you always subtract. So you're going to get 0.9772 minus 0.1587. That's going to give you the middle portion, which is 0.8185. As you can see, it's super close to the calculator answer. So that means we did it right. All right, we do got one final problem. I'm on 3%. My charge of the tablet is on 3%. I think we can do it. In a random sample of 500 college students, how many work at least 18 hours per week? All right, so it's the same premise. So let's see. Let's draw the distribution. Oh no, you don't even have to do that. So how many work at least 18 hours? Remember, we already did that. The percentage that work at least 18 hours was 50%. So all you have to do is find 50% of 500. Because they're saying in a random sample of 500 college students, how many of those work at least 18 hours per week? We know that the percentage of college students who work at least 18 is 50%. So in other words, all you have to do is multiply 500 college students times 0.50. And that's going to tell you how many. And the answer is 250 college students, half of them. So that one, we didn't even have to use, we didn't have to draw the distribution because we had already done that. At least 18 hours. We did that in part A.
Okay.
Well, that's the reason we didn't have to do it. But let's say it would have been 40%. Then you would have multiplied 500 times 40% or 0.40, and then you would have got a different answer. Well, that's how you figure out that. All right, so next class, we will do these last 3 problems that we didn't get to. But that is pretty much it. That was a lot of information. That's a lot of the statistics. That's a lot of statistics stuff that we learned today that you would learn in Math 150 if you were to take it. I know Tori's taken it before, but if you were to take 150, you would do a lot of this stuff that we just did right now. All right, well, let me take